This video is about ellipses, and so we're ready to move on in our conic sections. We looked at circles last time, and so if you look at your worksheet, you can imagine a cone being sliced by a plane at an angle, not perpendicular to its axis, but at an angle like this. And when it slices through, it's going to create an oval shape or an ellipse. So now we're going to look at how they're defined. Conic sections are all defined in terms of distances. So if you think of a circle is the set of points you get that are equidistant from a certain point called the center or the focus, if you want to think of it like that. We have a circle here. The circle is the set of points that are all the same distance from the point in the center called the focus, and that's how a circle is defined in terms of distances. And that distance from the center to any edge is the radius. Okay, an ellipse right here is an ellipse, and so I just happened to orient this one where its length is longer on the major axis. The longer axis is horizontal. It could also be oriented any other way, but the length, how it's defined in terms of distances is like this. It has, instead of one focus or a center, it has two important points called the foci. It has, and note that the focus of a curve, no matter what curve we're talking about, will always be located inside of the curve itself. So inside of the circle is the focus, inside of the ellipse is the foci. This will help you keep on track as to whether you've accidentally chosen the wrong equation. Later on we do hyperbolas and other things, and parabolas, making sure the graph, the foci will always be inside the graph itself. So here's our ellipse. This is how it's defined in terms of distances. The distance from this focus to the edge on the circle and this focus, if you add the distance from here and here, you get some number, let's call it k. And then if you add the number here, if you move, as you move around the circle, let's say, to this point, if we take the distance between F1 here to this point plus here to this point, it's that same value k. So a way of imagining this in your mind, and you probably did this maybe in elementary school, let's just say you have a string with a pencil on one end and a tack on one end. For a circle, you would stick the tack in the board and you would pull the string till it was tight, and then you would draw your pencil, with your pencil you would draw all the way around, and you would draw your circle like we use a compass for that. Okay, an ellipse, imagine that you had a string with a pencil, but you had at one end of the string you had a pin, and then at the other end you had another pin, and your pencil wasn't tied, and so you stuck a pin here at one focus and a pin here at the other focus. Okay, those are in. Then you took your pencil and you pulled it till your string was tight, and then you started drawing, and so you would start drawing. And so can you imagine in your mind that your string is both of the ends, it almost looks like a line, they're the same, and then they start splitting apart and they draw around here, and at this point they're both looks like a line, they're both the same right here, and you would draw all the way around here. That is how an ellipse is defined in terms of distances. Here's the equation for an ellipse. It is x squared over a squared plus y squared over b squared is equal to 1. Okay, always A is the horizontal distance from the center to the edge. So this distance, let me erase now that I've defined what that is, and you can look at the definition on your sheet. The distance from the center, so in this picture that I've drawn, this is the center, 0, 0, okay, at the origin. And so the distance from the center to horizontal end, whether it's oriented horizontal or vertically, is a unit. So this would be a comma 0, that would be that point. And in this case where the center is at the origin, if we go this length, this is a, so this is negative a, 0. And if we were to go up, this would be the vertical distance. So B however your ellipse is oriented, B is always the vertical distance from the center to a point on the ellipse. So from here to here is B units. This would be called 0B, this point. And from here to here, this would be 0, negative B. Now, whichever axis is longer is called the major axis. So, in this case, the way I've drawn it, A is the major axis. What happens on the major axis is all of the labeling goes on. These endpoints here are called vertices. Those are important. Vertices. I'm going to call this V1 and this V2. Also, on the axis, the major axis is where the foci will occur, and that's very important. So, for instance, real quick, if we had an ellipse, sort of, that was, let's just make it centered. Let me try better. Let's draw an ellipse centered vertically, longer vertically, centered at the origin. So let me just first try to draw something that sort of looks like an ellipse. We are just going to have to use our imagination. In online world, as if you guys were in the classroom with me, I would ask you guys to hang in there with me and pretend like I could draw, which I cannot. So it's longer this way. So in this case, let's see. In this case of our ellipse, this would be the point 0B. This would still be the point 0, negative B. The center would still be at 0, 0. This would still be the point A, 0. This would be the point negative A, 0. But if the longer axis is vertically, these get the labels V1, V2. The foci will lie on the major axis. So somewhere in here is F1, somewhere in here is F2. The distance from the center to a foci is, this distance is C, and I'm going to tell you what C is. So that's C right here. This would be C units, whichever case you're looking at. How do you find C? Well, this is the way I like to do it. I think it's the simplest to learn and to teach. And so here's a little caution. If you're looking on other websites about how to graph conic sections, the way that they talk about the A, the B, and the C may be different from what I'm about to tell you. So the way I'm telling you, it's the same in each one of our things, how you think about it. So this is how I like to talk about it. This is the equation of an ellipse, and C squared is equal to the absolute value of A squared minus B squared. So A is always the horizontal distance, B is always the vertical distance, and for an ellipse, this is the relationship that helps you find C. So with all of that, we're going to begin to do this. Oh, first let's talk about circle really, really quick. The equation of a circle, let's make it centered at the origin. X squared plus y squared is equal to the radius squared. Let's see, let's compare it with our equation of an ellipse right here. Let's compare it with these two. All right. What is the difference? Well, here's a big difference. There's a 1 over here, and there's a r squared over here. That's different. So can we make these look alike? We certainly can, and we can do that by dividing both sides of this equation by the radius squared. If we did that, we would get x squared over r squared plus y squared over r squared is equal to 1. It turns out that a circle is an ellipse, but it's a very special ellipse where the horizontal distance from here to here and the vertical distance from here to here, A and B are the same length, and that's the very special case of an ellipse that is a circle. All the other ellipses that we look at that are oblong, A or B are different sizes. One's longer than the other, and that's the ones that that this equation goes with, where A and B are not the same. Okay, so that's the similarities between circles and ellipses. Now let's look at our examples. The standard form ellipse on your worksheet looks a little bit different. What is the difference in what I wrote here and what's on your worksheet is the H and the K. So this one is centered at the origin. Because we don't see anything, we know that H and K are 0. When it's not centered at the origin, it's x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And c squared is the absolute value of a squared minus b squared, just like that. If you don't want to worry about the absolute value, you can just always think it's the bigger one minus the smaller one, and you'll see what I mean here in a second. Now let's do a couple of graphs, and then we'll take a break from this video. I'll break it up into two so that they don't get extremely long. The first example on our sheet, it says to graph the ellipse. So here we go. This is our ellipse. X minus 3 squared over 4 plus y minus 1 squared over 25 is equal to 1. All right, before you graph anything, as you learn these different conic sections, you're going to first want to decide what is it I'm looking at. Am I looking at a circle, a hyperbola, a parabola, ellipse? What am I looking at? We're under the heading of ellipse, and so we know this is an ellipse. We'll just compare. This fits the form, so this is an ellipse. Okay. So start to pick apart what you can. What is the center? What is the coordinates of the center? Well, the center is going to be the opposite of what I see here and the opposite of what I see here. So the center is going to be the point 3, 1. All right, what is the value of a? Well, if a squared is 4, then a is 2. Technically, a would be plus or minus 2, but negative distances don't make any sense, so we take the positive number. Square root of 25 plus or minus 5, we just take the positive because of distance. So b, because it's underneath y, is 5. Okay, great. Who is longer? Who's bigger? You're bigger. That means the major axis is on the y. Okay, so here we go. Let us graph this. And so this is how graphing goes when it's not centered at the origin. First, find the center because everything is based off of that. So go to the point 3, 1. 1, 2, 3, 1. So you may want to use graph paper when you're first doing this. However, you don't have to. You can do what I'm doing here. Then from the center, I'm going to go right 2 and left 2 because this is my horizontal marks. Right 2, so this is 3, this is 5, and left 2. This is 1, 1. This is this point, 1, 1, 1, 1. This is 5, 1, 3, 4, 5, 1, okay. Then from the center, right here, I'm going to go up 5 and down 5 because b is my vertical distance. So let's go up 5. 1, 1. Oops, that looks like it's not working. Is this working? No, it's not. So I'm going to get a different marker. Go up 5 and down 5. 1, 2, 3, 4, 5. From the center, I go up 5. So this point right here is 3, 6. And then I'm going to go down 5 from the center. 1, 2, 3, 4, 5. And put this mark here. And so this is going to be the point 3, negative 4. Now these get the labels V1, V2. So watch how to graph this. They do not have to be very good looking. I'm about to show you. I'm about to graph mine. And it's not going to look that great. So you can just fill it in the best you can. All right, there is my ellipse. The major axis is the vertical axis, okay? The minor axis is horizontal. These are my vertices. I need to label some things. What did it say? Label the... I'm supposed to label some stuff. Maybe it didn't tell me what to label, but I'm going to show you what you need to label. You need to label the center or have it labeled somewhere, the vertices, and the foci. So the foci are this. I got to know this relationship, that c squared is the absolute value of a squared minus b squared, or bigger minus smaller will give you the absolute value. So 25 minus 4, b squared minus a squared, is 21. So c is the square root, so this came from the square root of 21. Okay, now you will show me accuracy through the points that you label. So the square root of 21 is somewhere between the square root of 16 is 4, the square root of 25 is 5, so it's 4 point something. You can also use your calculator it's 4 point something. So that means from the center, I'm going to move up C and down C to find my foci. So from the center, which is at the point 3, 1, I'm going to go up 1, 2, 3, 4 point something, and I'm going to put my point and call that F1. I'm going to go down 1, 2, 3, 4 point something. I'm going to put my point. Oh, I labeled these both V1. I'm going to have to label one of them a second one. This is F2. Okay. So F1 and F2. F1 has the coordinate. The X coordinate is 3. The Y coordinate is, I was at 1. I'm at 3, 1. 1 plus square root of 21. And 1 minus the square root of 21. And so these are all the nice little things you need to label for your ellipse. Let's do the second example. It says, where does it say? Okay, write the equation of the ellipse in standard form, then identify the center and the values of A and B, and state the coordinates of the vertices and the coordinates of the minor axis, and sketch the graph. Okay, everything kind of what I just labeled. So let's do number 2, and it gave us this equation, 9x squared, 9x squared plus y squared is equal to 36. All right. So at first glance, you might go like, what is going on? That is totally not a circle, an ellipse, but it doesn't look exactly in the right form, but we can work on that. Remember how I said this is the equation of a circle and we divided everybody by the radius? We want this to be a 1. So let's divide both sides by 36 and it will look like we want it to look. So we'll divide both sides of this equation by 36. And what happens is here is we can simplify this fraction. 9 will go into 36 4 times. So this ends up being x squared over 4. What I did is I divided the numerator and the denominator by 9. 9 goes into 9 once and into 36 4 times. All right, so this is the equation of ellipse. The center is at the origin. We don't see a H or a K. All right. A squared is 4, so A is 2. B squared is 36, so B is 6. So this one's centered at the origin, okay? We're going to go right and left A. Right and left 2. 1, 2, 1, 2. We're going to go up and down 6 from the center. 1, 2, 3, 4, 5, 6. 0, 6. Down 1, 2, 3, 4, 5, 6. 0, negative 6. This is the point 2, 0. This is negative 2, 0. The center. And I'm going to call this the center because we also have the value C, so I don't want it to be confused. Okay, let's go ahead and find C while we're at it. The equation for ellipses is this one right here. The absolute value of A squared minus B squared, or where are we? Right here. When it's in this form, bigger B squared minus smaller A squared. So C squared is 36 minus 4. Or here, if you want to see what I'm saying, the absolute value of A squared, 4 minus 36, what would happen? This would be negative 32. And you would say, well, absolute value is a distance. How far is 32 from 0? It's 32. So this is 32. That's why I say you can just take bigger minus smaller. Okay. C is the square root of 32. This is going to be between 5 is 25, square root of 25 is 5, square root of 36 is 6, so it's going to be 5 point something. Again, you can use your calculator to figure that out if you want. But it's on the vertical axis, so let's go up and down. Square root of 32. 1, 2, 3, 4, 5 point something is a foci. Let's label these the first V1, F1. 1, 2, 3, 4, 5 point something. This is F2. I'm going to try to sketch my ellipse. Something like that. Okay. There it is. Okay, what did I have to label? I had to label the equation of the ellipse in standard form. Yes. The center. Yes. The values of A and B. Oh, okay, yeah. The coordinates of the vertices, yes. B2, okay. The minor axis coordinates, okay. Okay, that's what we had to label. It didn't ask for the foci, but I will on the test, so there it is. Okay, so that's, I'm gonna stop and we're gonna finish up this worksheet on a second video.